All these group 15 elements, when it is react with the hydrogen, it will form what? Hydrate. It has a higher stability to attract the shared pair of electrons towards itself. That is why it has a higher electronegativity. This is the colorless, odorless, and it is a tasteless, and also it is non-toxic gases. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called P block element. Under that, we have discussed about only the group 15, introduction to the P block elements, and we have learned about the general electronic configurations of group 15 elements, and we have learned about the occurrence, and we also learned about the general properties of group 15 elements, and also we have learned about the trends in their physical property. Today, let us move on to understand the trends in their chemical property, and we are going to understand the anomalous properties of nitrogen, and we are going to understand the preparations of nitrogen, and the physical properties of nitrogen we are going to study, and we are going to understand the chemical properties and uses of nitrogen, because already in my introduction class I have given that in this group of elements you are going to study in detail about the first element, that is nitrogen. Okay, so we'll see what is the trends in the chemical property. The first trend is oxidation state. When we are discussing with the group 15 elements, we know that it has general valence shell electronic configuration of NS2 NP3, NS2 NP3, and it shows the 5 electron in its valence shell. Hence, it shows -3, +3 and +5 oxidation state. So, how many common oxidation state will be exhibited by the group 15 elements? There are 3 common oxidation state will be exhibited by the group 15 elements. They are -3, +3 and +5. Coming into their trends in their periodic table, the tendency to shows -3 oxidation state decreases down the group because of the decreasing in electronegativity by increasing in atomic size. So, as we move down the group, what will happen to the tendency to attract the shared pair of electron towards itself? It is going to be decreased. That is why their -3 oxidation state gone decreases as we move down the group because of increasing in atomic size. And the bismuth practically does not shows -3 oxidation state. Coming into the +3 and +5, the stability of +5 oxidation state decreases, whereas the stability of +3 oxidation state will be increases due to the inert pair effect. I'll explain that by considering the valence shell electronic configuration. If you look at the valence shell electronic configuration, it is clear that it consists of 5 electrons in its outermost shell, that is in the valence shell. As we move down the group, the involvement of this NS2 will completely become inert. It will become inert, which indicates that this orbital, which consists of 2 electrons, will not involved in bonding. As a result of this, the +5 oxidation state will be decreases. The stability of +5 oxidation state will be decreases due to the increasing in +3 oxidation state. This effect we call it as inert pair effect. So for the 1 mark or for the 2 mark, they can ask you what is inert pair effect. So please understand, the group 15 elements, they shows the 3 common oxidation state. They are +3, +5 and -3, right? As we move down the group, what will happen? The involvement of NS2 shell will be completely become inert. It will not involve in a bonding at all. As a result of this, the +3 oxidation state will be get increased due to the decreasing in +5 oxidation state. And coming into only the nitrogen shows the oxidation state from -3 to +5. And if you consider the nitrogen and phosphorus together, it shows from +1 to +5 and undergo oxidation as well as the reduction in the acidic medium. This process we call it as disproportion reaction. You can understand this reaction here where 3HNO2 give rise to the HNO3 and water molecule and nitric oxide. This indicates that our nitrogen which shows the oxidation state from +1 to +4, but it do not shows the +5 oxidation state. Why nitrogen is not showing the +5 oxidation state? I'll explain in the next concept. Coming towards the next trend, the reactivity towards the hydrogen. So we'll understand how this group 15 elements will react with a hydrogen. All this group 15 elements, when it does react with a hydrogen, it will form what? Hydrate. It will form a hydrate, and generally we represent this hydrate as MH3. Okay. So the nitrogen can react with the hydrogen and forms the ammonia. Similarly, the phosphorus can react with the hydrogen and form a phosphine, and arsenic can react with the hydrogen and forms a arsine. Antimony can react with the hydrogen and forms a stibine, and bismuth can react with the hydrogen and forms a bismuthine. So this indicates that all these group 15 elements can easily react with a hydrogen and forms a hydrate. Okay. Then all these hydrates are colorless gases and their basic nature and thermal stability decreases from ammonia to bismuthine. So as we move down the group, what will happen to their basic characters? It started decreasing, and the first one is from the ammonia, it started decreasing towards the bismuthine. And the reducing nature gradually increases from ammonia to bismuthine. Ammonia is a weak reducing agent where bismuthine is a strongest reducing agent. Again, if you see the reducing nature down the group, the ammonia is the weakest, whereas the last element is a bismuthine, which is a strongest reducing agent. So this is all about their hydrate formation, and coming into their boiling point of this hydride. Okay, the boiling point increases with increasing in size due to the increasing in van der Waals forces, and boiling point of ammonia is more due to the hydrogen bonding as it is compared with the other hydrate. Just imagine you have two ammonia molecule. Okay. to ammonia molecule. So between the hydrogen and nitrogen, we can see that we have hydrogen bonding. Okay. Due to this hydrogen bonding, all this group 15 elements, they shows higher boiling point. Especially you can take the example of nitrogen, where nitrogen can easily form a hydrogen bonding with the other nitrogen molecule, thereby it exhibits the higher boiling point. Coming into their reactivity towards the oxygen, all these elements, they form oxides of type M2O3 and M2O5. So here you can consider M2O3 or E2O3 or E2O5. Why it is E2O3 or E2O5? Because already we have understood that it shows +3 to +5 oxidation state. That is why when it is react with the oxygen, it forms the oxides of the type E2O3 and E2O5. What does that E or M represent here? Again, it represents the element of group 50. Okay. The oxides in their higher oxidation state of the elements are more acidic than that of the lower oxidation state. Suppose if you consider the group 15 element, if any element is showing the higher oxidation state as +5, it is usually acidic in nature as that of the other element which are showing with the lower oxidation state. And the acidic nature of this oxides decreases down the group. As we move down the group, what will happen to their acidic nature? It will be decreased. Okay. And such as the N2O3 and P2O3 are distinctly acidic, whereas arsenic oxide and the antimony oxide are amphoteric, whereas the bismuth and oxide which are basic in nature. If you understand this, you can clearly say that how these elements which also shows the different oxide formation. So if you consider N2O3 and P2O3, that is nitrogen can form a nitrogen oxide, phosphorus can form a phosphorus oxide. So they usually acidic in nature. Okay. Coming into the arsenic and antimony, they are amphoteric in nature. They are amphoteric in nature. The last element, that is bismuth, can form basic oxide. So here the amphoteric oxide, the term indicates that this oxide can behave both as an acid as well as the base. But whereas nitrogen and phosphorus are purely acidic in nature, whereas bismuth can form an oxide and it is basic in nature. Okay. Next, coming towards the halogen. So let us understand how does it reacts towards the halogen. These elements can react to form a two series of halides. Again, it is represented as EX3 and EX5. What is E and X here? E is nothing but an element. X is nothing but a halogen. What are the halogen? Can you name the halogen? That is fluorine, chlorine, bromine and iodine. Fluorine, chlorine, bromine and iodine are the halogen. So when it does react with the halogen, it forms a metal halide. Okay. So nitrogen does not form a pentahalide due to the non-availability of d orbital. So already I have explained that nitrogen always exhibit +1 to +4 oxidation state, and it do not shows the +5 oxidation state because of the unavailability of d orbital. How? If you write the electronic configuration of the nitrogen, that is 1s2, 2s2, 2p3. So it is clear that there is no involvement of d orbital here. By that we can clearly understand that the nitrogen will not shows +5 oxidation state, hence it do not form a pentahalide because it do not contain what? D orbital. Okay. Then the pentahalides are covalent than trihalide. As I have explained that it can form trihalide. This is a trihalide and this is a pentahalide. So only the nitrogen will not form this pentahalide, whereas all this element can form a trihalide and pentahalide. Trihalides are except the beryllium trihalide, which prominently covalent in nature. So this is how we can clearly understand that how this group 15 elements, even though it is reacting with the halogen, it forms a different trihalides and pentahalide due to the variable oxidation state. Coming into the reactivity towards the metal. Now let us understand, after looking at with the halogen, hydrogen and oxygen, how does it can also react with the metal to form a compound. So all this element react with the metal to form a binary compounds, okay, exhibiting the -3 oxidation state. So such as the calcium nitride, calcium phosphide, sodium arsenide, zinc antimonide and magnesium bismuthide. So these are the element where you can write the calcium nitride, calcium phosphide and sodium arsenide and zinc antimonide and magnesium bismuthide. In all this element, especially our group 15 elements, it exhibit -3 as their oxidation state. -3 as their oxidation state, because when it is react with the metal, it forms a binary compound. So hope you all understood with this how it will react with the hydrogen, oxygen, halogen as well as with the metal. Now let us understand the first member in the group 15, the nitrogen, why it is different from the other elements in the same group. Okay, the nitrogen is the first member of group 15 and it is different from the other elements of group 15 because of the smaller size and the higher ionization enthalpy and higher electronegativity and absence of the d orbital in their valence shell. So when you compare the nitrogen with the other elements in the group 15, we all know that nitrogen is the first element where it is having very small size when it is compared with the phosphorus, right? So that is why, because of the smaller size and because of the higher ionization energy, which indicates that higher electronegativity, it is not so very easy to remove the last electron. It requires what? Large energy to require the last electron. So that is why it has higher ionization energy and also it has a higher stability to attract the shade pair of electron towards itself. That is why it has a higher electronegativity. And also, if you understand the general electronic configuration of nitrogen, it is Ns2, Np2 and there is no involvement of d orbital. There is no involvement of d orbital. That is why in the oxidation state I have explained that nitrogen will not shows plus Y oxidation state, it can show the oxidation state from +1 to +4. These are the anomalous properties of nitrogen. So, especially for the 3 marks, they can ask you to write the, or for the 2 marks also, they can ask you to write the anomalous properties of nitrogen. Then, why this nitrogen will look different from the other rest of the element? I'll explain by taking some of the examples. Okay. So, the differences between the properties of the nitrogen with the other member of the group 15, that is mainly because of the nitrogen can form p-pi and p-pi multiple bond with other nitrogen atom and only other smaller atom with a higher electronegativity. So, you can take the example of a triple bond formations between the nitrogen. We know that between the nitrogen there is a triple bond, one which is sigma and two are pi. So, it forms one sigma and two pi bond. That is why it looks different from the other rest of the elements. So, between the nitrogen and nitrogen molecule, we have one sigma and two pi bonds. Similarly, between the carbon and nitrogen, there is a triple bond, and also between the nitrogen and oxygen, we have double bond. Other group of the elements will not form some multiple bond, whereas that of the nitrogen. Only the nitrogen can form some multiple bond, whereas a carbon and a hydrogen, all these elements can form a single bond. That is why, because of the special characters, nitrogen will look different from the other group of the same element, will look different from other elements in the same group. And nitrogen molecule is a gas, whereas other member of this group 15 are solid. So, in their physical characters only, we have understood that nitrogen is only the metal which is exhibiting the gaseous state, whereas other metals, other elements, they are usually solid in nature. And nitrogen molecule has triple bond, whereas phosphorus, arsenic and antimony and bismuth can form a single bond between the atom. For example, if you take only the nitrogen, we know that it has a triple bond between the two nitrogen atoms, whereas phosphorus and phosphorus, arsenic and arsenic and antimony, even with the bismuth, between the atoms, they have a single bond. And nitrogen can exhibit the maximum covalency of 4 due to the presence of 2s and 2p orbital. The phosphorus and other elements shows d orbitals in their atoms, hence they form the pi-p pi bonds with the transition ions to form a coordination compound. This is already I have explained that why the nitrogen shows only the +4 to +4 oxidation state, because of the unavailability of d orbital. Okay, this is how we will understand the anomalous behavior of the nitrogen, why it is different from the other elements in the same group. Coming into their preparations, how we can prepare the nitrogen, we will understand now. Okay, nitrogen means it is usually dinitrogen. Okay, first is a laboratory preparation. So, in the laboratory, nitrogen can be easily prepared by heating the aqueous solution of ammonium chloride with sodium nitride. So, what will happen? This chloride and sodium will comes out as a solid, that is sodium chloride, and it forms a ammonium nitride which is unstable. Okay, later upon heating, this ammonium nitride will be loses its water molecule and forms a nitrogen along with water molecule. This is a first method of preparations of dinitrogen. Coming into the second method, by just heating the ammonium dichromate. What is that ammonium dichromate formula? NH4 twice Cr2 O7. By just heating this ammonium dichromate, you will get a nitrogen and Cr2O3 and water molecules which also get reduced. And coming into the barium azide or by using the sodium azide. By using the barium or with the sodium azide, we can easily prepare the pure nitrogen simply by doing the decomposition reaction. Okay. So, the barium nitride, which is upon decomposition reaction, it gives to the barium and dinitrogen. So, these are the only the three methods where we can easily prepare the nitrogen. Okay. So, which are those? First one is a laboratory method where you are going to take the aqueous solution of ammonium chloride allowed to react with sodium nitrate. It forms what? Ammonium nitrate, which is unstable, and that which is upon heating it gives rise to the dinitrogen. Coming into there, just by heating the ammonium dichromate, you will get a dinitrogen, and also by considering the barium nitride or with the sodium nitride, just by doing the decomposition reaction, you will get a pure nitrogen, that is dinitrogen. Coming into the physical properties of nitrogen. So, it is colorless, odorless, tasteless, and it is also one of the non-toxic gases. It is a colorless, odorless, and it is a tasteless, and also it is non-toxic gases, and it can be liquefied into colorless liquid with a boiling point of 195.8 degree Celsius, and it is non-combustible gas and it does not support the combustion, which indicates that during the combustion this gas will not involve and it does not support for the combustion, and it is slightly lighter than air and sparingly soluble in water. So, you can see that only 23.2 centimeter cube of per liter of the water at 273 Kelvin at what? Atmospheric pressure, that much is enough to dissolve the dinitrogen in water. That is why it is known as sparingly soluble in water. And coming into their two stable isotopes, the dinitrogen can form two stable isotopes. One is 14 nitrogen and 15 nitrogen. These are the two stable isotopes of nitrogen. Okay. Coming into their chemical properties of nitrogen. So, there are many chemical properties will be there. We'll understand one by one. It is chemically inert at room temperature due to their high bond dissociation energy. Already I have explained that between the two nitrogen atoms we have a triple bond. So, it is not so easy to remove this all the bonds between the two nitrogen atoms. So, it requires a higher energy, hence their bond dissociation energy which is also quite high. Okay, and it is around 946 kilojoules per mole. However, the reactivity will be increases with rise in temperature, and it can directly combine with oxygen at very high temperature like an electrical arc to give a nitric oxide. So, it can easily combine with the oxygen to form a nitric oxide. It can also combine with the hydrogen at a temperature around 773, it will form a ammonia. This process, which is one of the important process where you are going to prepare the ammonia by using hydrogen and nitrogen, this process we call it as Haber's process, and it gives rise to what? Ammonia. And we have one more reaction at temperature. It is directly combines with some of the other metal to form a predominantly ionic nitrates with the non-metal, and it forms a covalent hydride. You can see that the lithium is a metal where it reacts with the dinitrogen, it forms a lithium nitride. Similarly, the magnesium reacts with the nitrogen, dinitrogen, it forms a magnesium nitride. Okay, the metal will form what? Ionic nitride. Remember, metal will form what? Ionic nitride, whereas non-metal will form covalent nitride. This is how the metals and non-metal, even though it is reacting with the dihydrogen, it forms a covalent and ionic nitride. Okay. Coming into their uses, where exactly we are using the nitrogen. Nitrogen will be used to provide an inert atmosphere to the certain metallurgical processes, and it is used in manufacturing of ammonia, nitric acid, and in the calcium cyanide and with the other nitrogen compound. Okay, and it is also used for filling the electrical bulbs, and liquid nitrogen will be used as a refrigerant in the preservation of biological material, food items, and also in cryosurgery. So these are the some of the uses of nitrogen. So hope you are understood with all these properties of nitrogen and their behavior. By this, I like to say that what all the topics which I covered in this session, it is also important for the examination point of view. Have a look on it. We'll meet you with the next session. Till that, take care, be safe. Thank you.